Okay, so your puzzles that I gave you for homework, we are supposed to find two numbers that add to give you the same number and multiply to give you a different number. But these have to be the same two numbers. So we want two numbers that are going to add to give you 7 and that are going to multiply to give you 10. Katie? 5 and 2. 5 and 2 are going to be the correct answers for number 1. Because 2 times 5 give you 10 and 2 plus 5 give you 7. Now, I'm going to give you a hint. There are a lot more numbers that add to give you 7 than multiply to give you 10. So if you're stuck, you want to look at your factors of 10. What are the numbers that you can use? What are my factors of 10? 2 times 5, and what else? There's another factor. So we always start with 1. 1 times 10 is my factor of 10, and then 2 times 5. So that's always a good way to start. If you're not sure what to do, you can always look at your factors. The larger the number of the product, what does product mean? There you go. Product means the answer of a multiplication. Very good, Maggie. Product, the answer of our product, or the product is the answer of our multiplication. If we look at our product, the larger it gets, the more possibilities we're going to have, but that's always a good place to start. So number 2, raise your hand. Abby, what'd you get for number 2? Okay, 7 plus 2 is 9, and 7 times 2 is 14. That's perfect. All right, anybody get number 3? Chris? 1 plus 7 is 8, and 1 times 7 is 7. Very good. The next one is yours. All right, Hunter, what'd you get?
I got
Negative 9 plus 8 is negative 1. I agree with that.
And negative 9 times 8.
Is negative 9 times 8 equal to a positive 72?
Negative. You're wrong. You do 8 minus 9. That's what I meant. Can you change the what?
Well, you all tell me. Are they both negative? Is negative 9 and negative 8 equal to negative 1? No. Jack?
How can you even do that?
Yeah, I thought I had
If it's a negative times a positive, that's 72.
Ooh, Megan, what word is that back there? If this doesn't work, I agree with you that negative 9 plus 8 equals negative 1. But negative 9 plus negative 8, negative 9 plus 8 has to equal what? It equals negative 72. It doesn't equal positive 72. So if we had a negative 72, it would be correct, but written the way that Miss Baker had it written, what do we have to say? Prime. There is no answer. It doesn't work. That one doesn't work. We talked about that yesterday. That was mean, but that's my job. Well, can't help it if you're not here. I can't help it if you're not here. All right, so let's look at number 5. If you're not sure about number 5, let's start with 20. What are my factors of 20? 1 times 20, 2 and 10. Does 3 go into, and then 4 and 5. Blake? Negative 2 plus 10 equals 8. And negative 2 times 10 equals negative 20. Very good. See how making that list will help you? And look what happens with your list. See how it curves around? Once you get to that 4 times 5, that means you've got all of your factors. Who's got number 6 for me? Madeline, you have number 6 for me? 3 and negative 2. That's absolutely correct. 3 and negative 2. 3 times negative 2 gives me 6. Negative 6, pardon me. And 3 plus negative 2 gives me my positive 1. And Miss Baker was really tired when she was doing the homework last night, and so she gave you the exact same one for number 7 as she gave you for number 1, so we're back to 2 and what? 5. Alright, so, today, yes, Hunter?
I think that if you're that tired.
Okay, so we are going to go back to the trinomials that we were factoring yesterday. If you remember, we are using our puzzles in order to factor trinomials. And our trinomials are in our quadratic, our quadratic standard equation, right, of ax squared plus bx plus c, our quadratic form. And so I'm going to use x squared plus 7x plus 10 because my first puzzle that we used last night had 7 and 10. Why do I want to use that? Because if we write, what's our standard form? Ax squared plus c, and then my puzzle is something plus
something
equals b. Say it with me. Something plus something equals b. Something times something equals a times c. Okay, so my b is 7 and my a times c is 1 times 10, which is 10. Put it away. Don't get it out again. We've already figured out that our answer to our puzzle is what, ladies and gentlemen? 5 and 2. Yes, Hunter?
Whenever we're doing this, we always do it like in the middle term, right?
Yes, the whole reason for the puzzle is we are splitting our middle term. We always have something like x squared, do we not? When we have our box, we always have an x squared and we always have a constant, but it's those x's that we normally split into two different places. Here's my x squared, here's my plus 10, but I need to do something with this 7x. You agree with me, Brian, that 2 plus 5 is 7. So, what can I do with this 7x? If 2 plus 5 is 7, then can I split it into 2x plus 5x? Is that legal? So I can trade in my 7x for 2x plus 5x. Yes, Bob?
I don't understand how there's certain things that you can't split up into. Like yesterday, you split it up into something that you want. But you can split it into 5 and 2.
What are some, I mean, if you can split 7x into 1 plus 6x, or 1x plus 6x, we can split it into 2x plus 5x, we can split it into 3x plus 4x, we can split it into 4 plus 3, but it doesn't, we can't factor it. It's, remember with our algebra tiles, it's not going to make our rectangle and factor properly if we don't split it into 2x plus 5x.
There's only a certain way you can split it.
Yes, and that's what the puzzle is for. It will not factor our binomials correctly if you don't. Yes. Yes. No.
Okay, so what is it? X squared plus 2x plus 5x plus 6. Another one like 3x. Or is that just like a whole other?
That's a whole nother type of factoring. That would, you already have 4, so you wouldn't use the puzzle if you already have 4.
Oh.
Yes, Chris.
You split from 7. Most people do like 8x minus 1. You get 7.
That's the whole point of the puzzle. We wouldn't be doing the puzzle if we could just split it into anything. We have to do the puzzle to find the two terms that we're going to split for this particular problem. Yes. So, now, we've used our puzzle to know exactly what to split into. Matt, what's my greatest common factor of the first row? X. Call on somebody else. Joey, what's my greatest common factor of the second row? Row. X. Just 5. And since this is positive, we're going to leave it as positive. Joey, call on somebody else. Casey, what's my greatest common factor of the first column? X. Casey, call on somebody else. Vanessa, what's my greatest common factor of the second column? And is it going to be positive or negative? It's going to be a positive. So, you can check your work. What is x times x? What is x times a positive 2? What is 5 times x? And what is 5 times 2? 10. What are my two binomials here that are my answers? Does it matter which order we write them in?
And then you're done? Is that all we do?
That's what we're looking for. We're looking for the two binomials. We are factoring the trinomial into the two binomials that we originally started with. That is what your answer is going to look like. Yes. You are factoring your trinomial into the two binomials. Yes. You are factoring your trinomial. Yes. Alright. I've used 9 and 14. So I'm going to write a polynomial of x squared plus 9x plus 14. So my puzzle is something plus something equals 9, because that was my B, and something times something equals A times C, or 14, because it's 1 times 14. I'm just using the puzzles that we used last night. It always adds to your B, and it always multiplies to A times C. Always, always, always.
Oh, I know that. Oh, we already did.
So, the puzzle is what? 7 and 2. Cole, what do I use the 7 and 2 for? Well, Brian said that when my puzzle was 5 and 2, he used the 5 and 2 to say that if 5 plus 2 is 7, then I can say 2x plus 5x is 7x. So if 7 plus 2 is 9, what can I do here? Well, you're just breaking this down into 7x plus 2x. And then in the interest of time, all of this is going to be brought down. What do we have? X squared plus 7x plus 2x plus. Now I have how many terms? 4. Where do they go? In the block. Abby, let me make it through because I'm about to run out of time. So let me finish and then we'll ask questions. GCF, go. GCF, go. GCF, go. I don't know why I wrote 2. This one is X. This one is 7. So what are my binomials?